Welcome to the part 2 of this lecture. In the previous video, we discussed the introductory concepts related to the construction activities during the software development. In this video, we will discuss quality assurance activities during the construction phase. So here we will see what is the relationship of software construction with the software quality. Weinberg has identified 4 targets which a good program should meet, and in fact these are indicators of the code quality as well. So the first one is, does a program meet its specifications, like correct output for each possible input? So if a program meets its specifications or produces the correct outputs, it is considered to be a quality program, and that's what we had discussed in our definitions of software quality. Then is the program produced on schedule and within budget? Again, the same. That is, if a product is completed under the schedule or budgetary constraints, it is assumed to be a quality product. And then how adaptable is the program to cope with changing requirements? That is, how easy it is to modify program or code to accommodate the newly arising or the changing requirements. Then is the program efficient enough for the environment in which it is used? Uh, this is obvious that it is in fact related to efficiency, which is actually a quality attributes, and we already know that performance requirements determine the quality of a program. So if a program actually is efficient, or efficiently performs its intended tasks, it is actually a quality program. Then why should you care about code quality? In fact, there are several benefits for having quality code from the perspective of developers or testers. These benefits include, for example, like readability, maintainability, lower technical debt. That is, quality code is readable. That is, it is readable to comprehend for everyone who is working on the project. It's in fact much harder to read and understand a bad quality code than to write it from scratch in some cases. So here, in fact, the readability is also related to following the code writing practices that are suggested by different standards. Then maintainability. That is, it's easier and less time consuming to maintain and test the quality code. Then lower technical debt means good quality code can speed up long-term software development, since it can be reused, and the developers don't have to spend like much time on fixing the issues that are there in the uh, issues or bugs that are there in the code. It also makes it easier for new project members to join the project while effectively and easily reusing the existing code. Here we will discuss quality assurance activities in construction phase. So there are mainly 2 types of activities that are performed during the construction. The first one is inspections, whereas the second one is walkthroughs. So here, in fact, these activities they are performed in order to evaluate the code. In this table, we have a comparison of the inspection and walkthrough. Uh, in fact, in these two techniques, the difference is much in terms of the structure of these activities. For example, inspections, they are like formal activities where these inspection activities, they are planned ahead of time with appropriate team structures, whereas the walkthroughs, they are like informal, that it might not be planned well before time or ahead of time. So anyhow, like whatever their structure is, uh, the primary task of both these activities is to evaluate the code or the construction work product. So here we see the differences, that the first one is that inspection is formal, whereas walkthroughs are informal. Then inspection is initiated by the project team, whereas the walkthrough may be initiated by the author. So in case of inspection, the inspection activity might be actually originated by the project manager or any other responsible individual. Then a planned meeting with fixed roles assigned to all the members involved in case of inspection, whereas walkthroughs, they might not be planned always. Then for inspection, reader reads the product code and everybody inspects it and comes up with defects in the code. Whereas in walkthroughs, author reads the product code and his teammate come up with defects and or any suggestions. Then in inspections, recorder records the defects, whereas in case of walkthroughs, author makes a note of defects and suggestions that are given by the team. Then in case of inspection, the moderator has a role in making sure that the discussions proceed on the productive lines. That is, a moderator's role here is to manage or control the overall session, whereas as I mentioned before, that walkthroughs are informal, so there is no moderator usually. So the activities might be controlled by the author of the code or anybody else. Then inspections are used to verify the compliance of the product with specified standards and requirements. It is done by examining, comparing the product with the design, code artifacts, and other documentation that is available. Whereas in case of walkthroughs, the authors actually present the developed product or the developed code to the peers or the team who is walking through. Then peers question and comment on the artifact to identify the defects and errors. Then inspections, they are in fact led by moderator. So moderator's responsibility is to make sure that meeting is successful, whereas the walkthroughs, they are usually led by authors. So here we see that these two quality assurance activities, they do have a different structure or a different format, but their primary intention is that they are meant to identify the defects or problems in the code. Okay, here we have an error checklist for inspection activity. So, in fact, we are interested in looking at errors of different types. For example, data or reference errors. Like, for example, we might be interested in looking that does a referenced variable have a value that is like unset or uninitialized. So since this activity is related to identifying problems or defects in the code, therefore we need to be very focused towards looking at the code with respect to the items that are mentioned here in the checklist. So similarly, we may be interested in like declaration errors. For example, like have all the variables that are used in the program that are declared or not. Similarly, we may be interested in looking at computation errors. For example, are there any computations that use variables having like inconsistent data types? Similarly, comparison errors might be looked for example, like are there any comparisons between variables having different data types, such as comparing a character string to an address, date, or any other number data type. Similarly, control flow errors might be looked for. For example, here, like we might be interested in seeing that, like, will every loop eventually terminate? So here we have to devise an, for example, informal proof of argument showing that each loop will terminate. Then interface errors, like does the number of parameters, for example, received by the module are equal to the number of arguments sent by each of the calling modules. Similarly, input and output errors might be considered. For example, if files are like explicitly declared, or are their attributes correct? So in the next slides, we will see some examples of more examples that show that what actually we should be looking for when we are performing the inspection activities. So here are more details about the elements of checklist that we discussed in the previous slide. For example, for data reference, we have lots of different like aspects that need to be considered. For example, we may look for like if any unset variable is used. Similarly, like subscripts are like within bounds, like are there any non-integer subscripts? Similarly, are there any dangling references or references to the non-existent objects? Similarly, like correct attributes when aliasing. So there is in fact a long list. Similarly, like for computation errors, like we may look for example, like are computations on non-arithmetic variables being performed? Similarly, what about mixed mode computations? Similarly, computations on variables of different lengths and so on. Uh, then, we have a similar list related to data declarations. For example, all variables are declared, default attributes are understood, arrays and strings are initialized properly. Similarly, for comparison, we have comparisons between inconsistent variables are performed. Similarly, like mixed mode comparisons are being performed. Like are the comparison operators correct? Because for example, sometimes programmer frequently confuse such relations. For example, less than, greater than, less than or equal to, greater than, equal to. Similarly, comparisons and Boolean expressions, they are mixed. Similarly, for control flow, you may be interested in for example, branching statements just to know about the flow of control. Similarly, we may look for like, will each loop terminate? Will the program terminate? Does any loop bypass because of the entry conditions, and so on. Similarly, here is a list of input and output as well. For example, file attributes, they are cracked. The open statements for opening files, they are cracked. Similarly, format specification matches with the IO statements, and so on. Then inspect interface related uh, aspects that might be considered. For example, number of input parameters are equal to the number of arguments or not. Similarly, parameters and argument unit systems are their types, do they match? Similarly, number of arguments transmitted to the call module equal to the number of parameters, and like many other interfacing aspects that might be looked for here while we are inspecting the code. Then some other checks may also be applied. For example, any unreferenced variables in the cross-reference listing, they may also be checked. Then like attribute list, what was expected, like similarly any warning information or warning or informational messages, they may be looked for here, and like for input is checked for validity. So here in fact we are actually interested in looking the code from identifying from the perspective of identifying errors. For example, as we saw that there might be data reference errors, data declaration errors, computation or comparison errors. So they all have to be looked here while we are in the process of inspection. So that's all about our discussion on quality assurance activities in software construction. The materials in this video are based on these three sources. For more details, you can consult these sources. Thank you.